algebraic equations can create shapes and designs using the Desmos Graphing Calculator. Everything you see on this screen is controlled by math equations, lines, curves, circles, and even more complex designs, all from algebra. Let's start with something simple. First, I'll type the equation y is equal to x. As you can see, Desmos immediately draws a straight line across the graph. This line has a slope of 1, meaning for every step to the right, the graph goes 1 unit up. This is one of the most basic examples of a linear equation. Now let's change it slightly. Now, y is equal to 2x. Now, the line becomes deeper. That's because the slope is now 2. So for every unit we move right, the line goes up by 2 units. This shows how algebra controls the geometry of the graph. Now let's try something curved. Y is equal to x squared. Now, we see a parabola. Instead of a straight line, the graph curves upward on both sides, which is the second degree polynomial. Parabolas appear all over mathematics and physics, especially in things like projectile motion. Now, let's move into some geometry. I'm going to type the equation x squared plus y squared is equal to 9. And now we get a circle. Why does this work? Because the equation represents all points that are exactly 3 units away from the center. Since the square root of 9 is 3, so algebra is describing a geometric rule. No. Let's move into some geometry. I'm going to type the equation x squared plus y squared is equal to 9. And now we get a circle. But why does this work? Because the equation represents all points that are exactly 3 units away from the center. Since the square root of 9 is 3. So algebra is describing a geometric rule, and Desmos turns it into a shape. Now, let's build a shape using multiple equations. First, I'll create the top of the circle. Y equals the square root, and then parentheses, 9 minus x squared. This gives us the northern hemisphere. Now, let's do the same thing. Y equals negative square root of parentheses, 9 minus x squared. And now we get a bottom hemisphere, or the southern. Together, these two equations also create a circle, but this time we built it using functions instead of a single equation. This is where graphing is really interesting. By combining different equations, we can create patterns and designs. For example, if I add a few straight lines like y equals x plus 2 and y equals negative x plus 2, you can see the lines intersect and form geometric shapes somehow. Mathematicians and artists sometimes use graphing tools like Desmos to create complex designs and tally from equations. Everything you see is still math. Lines from linear equations, curves come from quadratic or higher degree equations, circles come from distant formulas, and when we combine them, we can create almost any geometric figure. Math becomes much more interesting when you see it visually like that. Now, for my final trick, I would like to send a gift for all 500 of my subscribers. Thank you so much for subscribing to my channel since last year, January 10th, since I first posted the video. Well, yeah, last year, 2025. Anyways, enough of that, let's just get to the shape. So first, we're gonna have to do x and x 2 over 3. That will be the base of it. Then we have to make it positive. At square root, make it 3 minus x to the second. This will create the arch. Now, then parentheses 16 pi and 6. There you have it. all my subscribers who have stuck with me since my very first video. Thank you so much for subscribing, and thank you so much for watching this video, and I hope you have a great time. See you later.